during the questions period at the end. Aric LaBarr is an associate professor of analytics at the Institute for Advanced Analytics at NC State. Aric helps innovate the current structure of education to better prepare a modern workforce ready to communicate and handle a data-driven future. He develops and teaches courses in statistics, mathematics, finance, risk management, and operations research. His focus is teaching, mentoring, and serving students as well as businesses on modern analytical techniques for making data-driven decisions. And we're so excited to have him today. Aric, I'm handing it over to you.
Awesome. Thank you so much, Emily. Welcome, everybody. I'm very excited to be doing a webinar here on really what data science means to an executive. A little bit of background on myself. Emily gave a great introduction. Most of my degrees, well, actually all of my educational degrees came from NC State. My last one being a PhD in statistics with a focus on statistical finance and economics. And really before I was even in grad school, I was an economic analyst for a local market research firm. And then while I was a professor, I took a year to year and a half of what you might call a sabbatical to be a senior data scientist and eventually a director of data science at a consulting firm, Elder Research, that's based in Charlottesville, Virginia. So I've had a lot of different perspectives over the years, everything from a worker bee analyst all the way up to dealing with executives on how to be able to implement data science. And that's really where this talk sort of came from, is that idea of what data science means to an executive. And really this talk is really trying to be a bridge between data scientists and executives to try and get them to see each other's perspective on things. And that actually leads me into the very first thing I want you guys to notice about the slides. At the very top of the slides, you'll actually see two symbols. You'll see a calculator, data scientist, that is meant to represent your perspective, and you'll see a globe, executives, that is meant to represent your perspective. Now, obviously, you guys are going to be paying attention to the whole webinar, but I want you to be paying extra attention to the symbol that is not yours. So data scientists, whenever you see the globe, pay extra attention because that's an executive's point of view on the same problems that you might be going through. And executives, anytime you see the calculator, I want you to pay special attention because that's what the data scientists are going through when they're trying to solve a problem. So again, I'm trying to be able to close that gap and sort of bridge between data scientists and executives. So let's go ahead, jump in and get started. The hype around analytics and data science is overwhelming. Let's be honest. We see basically new articles on it every single day, right? However, most of the hype that I've noticed seems to be around the idea of modeling. So you hear all these great things, AI, machine learning, deep neural networks, big data, et cetera, et cetera. I could go on and on. In a real world application though, the data preparation and understanding of the problem at hand, as well as the deployment and integration, take up more time in the process than the actual modeling. So I want both data scientists and executives to sort of break the cycle of the hype around data science being all about the fancy modeling in the middle, when really without the two sides on the other side, the understanding and the integration, we would never be able to actually get the solutions that we want to be meaningful. So really, this is actually sort of a layout of the rest of the webinar. I'm going to go through each one of these sections, preparation and understanding, modeling, and deployment and integration, again, from both perspectives, a data scientist as well as an executive. So jumping on in a little bit more, preparation and understanding. From the very first thing you do when it comes to looking at a data science project, you have to figure out which project you even want to go with. And data scientists and executives both have different opinions on this. So that's actually why you see both symbols at the top of the slide here. In all of my experiences with data scientists, we like having new and exciting kinds of problems, things that are just something that we haven't worked on before. We also like solving advanced kind of problems, not just the normal day-to-day kinds of problems, but ways to solve problems that, again, other people may not have done regularly. Data scientists also love to feel supported in the whole process. They want to be encouraged. They want to know that their work is being looked at and valued. From the other side of things, the executives, though, are trying to be able to push an analytics initiative going forward. So that being the case, they're looking to start small. They're looking to fail fast. They want to be able to see marketable return on their investment early to be able to continue the momentum that they can have in bringing along an analytics initiative. And although these might seem like counterintuitive things that these people might not be able to get along, there is a great thing that they both have in common. And that is both the data scientist and an executive wants whatever they do in data science to be impactful. Data scientists love making change, and executives love seeing change. They want impact. Both sides do. And that's really where we can have some common ground. But to be able to make that impact, one thing that we need to do as data scientists that I think we can do better is we need to listen and ask questions of executives. Executives are trying to be able to describe the problems that they have to us. And so listening requires two things to be able to understand those problems. First is desire. The second is humility. The hardest part of any data science project is truly understanding the results that are wanted. And we can't underestimate this piece of the puzzle. We have to lay out plans. We have to have multiple meetings. We have to define what success even looks like. Without any knowledge of what success looks like, all you're going to do is just run down a path of modeling and never know when you're done. Understanding what an executive thinks when they see the results you've given them is very, very meaningful. Now, I'm going to tell you guys a lot of stories as this webinar goes on. So one of the stories is there have been many times I've been sitting in a room as a consultant with executives trying to understand the problem at hand. And I cannot tell you how many times I have been asked if all of these meetings were really that important. It's like, why are you asking me so many questions? Why does it matter so much? And the only thing I can respond to that is that I have never had a project not be successful because I've asked too many questions. Now, on the other hand, I have had projects be unsuccessful because I didn't ask enough questions. And so again, listening and asking questions of executives is imperative to any data scientist to be able to understand what's going on in an executive's mind. Same idea though. Data scientists, we're not going to be able to build the Death Star in one foul swoop. Patience is a virtue here. We need to start small and win big. That's really how we can progress and understand these things. Small successes that have good results can show quick value, which gains momentum. Gaining momentum can change a culture of an organization. They can start thinking about data in a different way. It now becomes a tool to assist them and not a threat to replace them. Again, I can give you a story around this. So I had a company that I was working with. The higher levels were very interested in the idea of analytics. They knew they needed it. But the users of the analytics were rather unsure. They were a little hesitant about what these data scientists were going to come in and be able to do. They had a process that essentially had them optimizing 1,000 or more different things at the same time. They basically had a large portion of money that they needed to allocate to 1,000 different divisions to understand where the money would go to be able to best drive revenue. Now, there's a lot of things that we can unpack about that, right? I need to be able to optimize how they can actually allocate the money, but the best way to do that is for me to forecast what each division would do. So I need to be able to forecast those divisions out. Once I know what the forecasts are, I can then try and optimize in the future what I think the best thing is going to be. So there's a lot of things that we can do, and there's a grand solution to this. But the very first thing that needed to be done was that the process on how to even optimize this had to be solved. See, the way they optimized this was through an Excel spreadsheet. Well, many Excel spreadsheets in all reality. all they really did was they optimized, quote unquote, the biggest pieces. They took the biggest things that were the most important to them and tried to figure out the best amount of money to give the rest based on just throwing it out there and saying, hey, everyone else gets an equal amount. I know these few things get something better. Now, the downside also is this was in addition to their normal jobs, and it took significant time to actually do. So starting small, what we basically came in and did was said, you know, we can make this process faster. We can worry about the forecasting. We can worry about everything else later on, but why don't we just make this faster for you guys so that when you try and allocate these resources, you know where to put money. So when you make a change in one, the algorithm will be able to make a change all the way around. And that's exactly what we did. We started small, and later on, we won big because of it. Now, another thing that's wrapped up in this is the idea of return on investment, net present value. Data scientists need to understand the language of the executive. How valuable is the project you are about to work on? That's going to help sell me on whether or not I should actually fund that project and I should actually support it. If you just come in and tell me, I can get you more money, well, that's great. I've had a lot of people walk into my office and tell me they're going to give me more money. The question is, how much more money? And is it worth it to me? And so again, there might be some rough assumptions involved in the process, but trying to show some notion of value before a project gets started can go a long way into getting support and buy-in from a leader. So again, let's take that last problem that I made mention to you on the previous slide. We had an optimization that needed to be fixed, a process that needed to be better. Well, we made some rough assumptions. We said, how long does it take these people to actually do this optimization, which, by the way, again, was outside of their normal job? They told us, well, it took 5 people about 2 weeks. They had to basically lock themselves in a conference room, come back and try and hash out where all of this money was going to go. And then one person had to sort of maintain the process about 2 days per month the rest of the year to be able, as things change, to be able to react to it. Okay, all right, so that's helpful. So 5 people for 2 weeks, 1 person for 2 days for the remaining 11 months. Let's just go ahead and say that those individuals could earn about $100 an hour worth of value to the company if they were actually doing their normal jobs instead of sort of being pulled aside to do this. So all we did was calculate a net present value, and we did it over 3 years. And all a net present value really is, it's just a current calculation of how much in today's money you're going to spend on something over a future period of time. So for example, we took the current cost of how much we thought it would cost the company to do this current process. Then we took the cost next year, and then the cost of the year after that. And it's just basic math, nothing too fancy. 5 people, 80 hours, 16 hours for 11 months, all at $100 an hour, gives you about $57,600. So they were essentially taking $57,600 worth of really lost value in these employees every single year going forward. So we basically walked into the executives and said, right now we are currently spending about $158,000 on this process over the next 3 years. If we could make this better, would this be valuable to you? It's like, oh, well, yes, it would. Now, again, they were a multi-billion-dollar company. Is $158,000, a lot to them? No, but it was a small project that they knew they could get a quick win on. Again, we're trying to have the executives believe in the process, and they're trying to sell it to the rest of the company. So again, quick win, but it could lead to a bigger win going down the road. All right, so I think I've picked on the data scientists enough and told them what executives think. Now it's time to pick on the executives a little bit and think about what data scientists have to go through. One of the major pieces of any data science project is really data preparation and governance. And I think all of life's problems can be explained through the Dilbert comic by Scott Adams. So I'm just going to let you all take a moment to soak this in and just read it. So a lot of executives don't understand the data limitations of the requests that they make. You know, again, story time. I had a company once who wanted to forecast revenue. Great. That sounds wonderful. Sounds easy. Okay, straightforward. You guys have historical information on revenue, right? Yeah, we have got historical information on revenue. All we need to do is try and forecast that forward. Perfect, great. Where is that historical information on revenue stored? Oh, I think it was on Tim's laptop. Oh, cool. Where's Tim? Oh, he doesn't work here anymore. I think they gave his laptop to Tina. All right, that's fine. That's fine. Anyone else? Is there a central location for this? No. All right, cool. Well, that's fine. We can get the spreadsheets. Well, they're not really spreadsheets. They're PDF files of tables. Oh, okay. So you have PDFs of spreadsheets that are spread out on people's laptops that you want me to collect and forecast revenue. Yeah, that's it. Exactly. So again, these are the kinds of problems that data scientists run into. It's like, okay, now the problem just got exponentially harder because I have to go find this and I have to extract this information. So I think sometimes executives don't always appreciate the problem of the data and how data scientists can get their hands on it. This is why IT needs to be in these conversations from the very, very beginning. Executives, data scientists, and the IT department all need to be involved in the conversations around what kind of projects need to get done, because the best people to be able to get you the data are probably the people in IT who know where the data might be located, or even if they don't, they can help you get it. Their buy-in is imperative to the success of any new analytics project, because now we got to start asking questions, right? Where should the data be stored going forward? I don't want to keep it on Tina's laptop, and I definitely don't want to keep it in PDF files. Okay, that's great, but who owns the data? So we have the data stored somewhere, but who actually owns it? Whose job is it to maintain that data, to make sure it's up to date? So these are the kinds of questions that data scientists have to deal with ahead of time. And really, executives, data scientists need your leadership and your support to be able to make these things run well. Empowerment, meeting with the right people, room for experimentation, room for failure. These are the kinds of things that any data scientist or any data science group can value, because that shows them that leadership has their back on being able to solve these projects. So I've worked with a variety of companies over the years, and I'm going to give you a couple of them, not by name. One of them had a new, fully funded analytics group, and really you could say culture. They invested both time and money into the process. They understood that some of the projects they were requesting, because they've never solved them before, that it may not be as fruitful as they were hoping initially, but they were willing to move through that and know that in the long run, this was going to be a worthwhile endeavor. Another company I worked for really sort of started analytics because they were told they should, but they were always hesitant about it. And the first sign of any problem, they pulled the plug. They said, oh man, yeah, you're right. Our data is a little uglier than we originally thought. Okay, that's it. We're not doing this anymore. We're out. It's like, whoa, wait a minute. Why? And really, it was because they didn't really have any faith in the process to begin with. Failure was imminent based on data problems, but they weren't willing to stick through. The chart, the figure that you see here on the slide, and I apologize for how blurry it is the cross-industry standard process for data mining. Some people call it CRISP-DM. It really is sort of the layout on how people solve data science and analytics projects. And in the very beginning, you can see the business understanding and the data understanding, as well as the data preparation, is very, very important. There's a lot of back and forth, making sure we understand what's going on. And leadership, you can help with supporting that. The more you support it, the easier it's going to be on a data scientist. Now, all of this is tied together through communication. everything I previously mentioned circles around communication. Without communication, none of the things that I previously mentioned will work. Deciding on the right project, knowing what is low-hanging fruit to start with, evaluating a good starting project, starting small, hoping to win big, handling the data concerns, meeting with the right people, bringing in IT, understanding how the value you're going to get out of these projects will look, and bringing in leadership all deals with good communication. And just like with listening, communication takes two things to be successful: desire as well as humility. You got to want to be able to communicate with others. And you have to understand that you don't know all the answers and you need other people's help to be able to solve this problem. With those two things, you can have a successful analytics initiative. And that really brings us to the end of the preparation and understanding portion. And now we get into modeling. All right, now the data scientists are starting to get excited. All right, cool. We're getting into the modeling, the exciting stuff. Well, one thing that I want both data scientists as well as executives to appreciate and know is that subject matter experts are valuable. In fact, subject matter experts, SMEs as they're sometimes called, are the lifeblood of any analytics problem. They can make the difference between success and failure in the modeling phase. Subject matter experts tie the analytics problem and the solution back to implementation, back to regulation, and back to deployment. Data scientists, we need subject matter experts to be able to help guide us on the problem, as well as answer specific questions that would drive results and insights. Like I had mentioned earlier to you guys, I come from the background of statistical finance, and there's a lot of regulations in that world. And because there's a lot of regulations in that world, subject matter experts that understand those regulations are going to protect data scientists and the models that they build, because there's no point in a data scientist submitting a model that cannot pass regulation. Now, executives need subject matter experts to be a bridge to data scientists, to make sure the problem has the correct focus and to ensure that solutions that are provided work in the business as a whole, not just at the one single modeling situation that they have on hand. Again, subject matter experts not only help us in the idea of whether our model will be approved, but how would our model actually work? And what do these variables actually mean so that we can understand what kind of insights we can obtain from the modeling that we do. One caution on subject matter experts, again, story time. We had a subject matter expert on one of the problems that we worked on that, let's just say, needed a little bit broader of a perspective. Subject matter experts might be just that, subject matter experts on their own subject, without the company as a whole in mind. Now, we were provided a subject matter expert who helped us craft a solution for what he and his team did, but didn't really actually help us too much on what was used outside of the team. I mean, that's okay. We were all sitting in a room presenting our results. The only person smiling in the room was a subject matter expert. He's like, "This is amazing. My job just got so much better." And then everyone else in the room's like, "Wow, this is not helpful." And so just be careful. A team of subject matter experts is probably the best. I'll be honest, this was our fault. We did not do our due diligence ahead of time to know what other uses might be out there and to ensure that we really had the perspective as on the company as a whole instead of just one individual subject matter expert. So that's just one cautionary tale. They're very, very valuable. Just make sure you have a team of them as best as you can. Alrighty, so executives, time to sort of look at some of these things. Again, what do data scientists have to worry and concern themselves with? Again, data preparation and governance. This takes place throughout the whole process. As the modeling process goes on, where are the analytics base tables going to be stored? An analytics base table is really a feature engineered data set, a data set that's not the raw data, but a data set that's been prepared for modeling. You know, we've cleaned it, removed missing values, maybe imputed missing values. We've created new variables as combinations of other variables. We aggregated certain pieces of data. Maybe we subsetted pieces of data. But now this data, I apologize. Now this data is ready for modeling. Well, where do we store it? Again, where is this data set that's ready for modeling stored? And then once we're done with modeling, where are the results from this model stored? I'll be honest with you. I've seen everything from data ponds to data lakes to data silos. I've even had people refer to things as data barns. I mean, let's be honest, we're essentially building an entire data farm at that point. But again, wherever you store it and whatever you want to call it, who owns this collection of models and data is an important question to ask. Again, where is it going to be stored? These are the concerns and questions of the data science teams that executives could help with. Because without any direction, data scientists are going to basically store it on their laptops, and now we run into the same problem that we ran into earlier. What happens when Tim or Tina leave the company and no one really knows where any of the results from any of the models they built are? Now, one thing as well, people are always looking for the quick out when it comes to the process of data science and analytics. I'll be honest, executives, I used to be a data scientist and still kind of am. Methods taken by us data scientists, they might seem a little cumbersome by some people. But typically, there's a method to our madness. The assumptions that we care about, that we're trying to solve, drive the inferences that we can make. These inferences that we make, they're going to drive the insights. And these insights are going to drive the decisions that you have to make. And so there is no shortcut. We need leeway to experiment and possibly fail when going down a path. We don't know ahead of time what's the best process and what's the best model that's going to work. This is always something that I teach my students as well. You always get the question, well, which technique is the best one to solve this problem? If I only knew. If I only knew. Unfortunately, I don't. That's why we try multiples and see which one works best. It's just like solving any maze, right? Sometimes you might get lucky, and the first path that you choose is the path that gets you out of the maze. Unfortunately, a lot of times, though, we go down a path, go, oops, well, can't go that way. Turn around, go back, and try again. And so there are no shortcuts in this process. And so data scientists always have to worry about a methodical way and sometimes a cumbersome way of doing things because we don't always know the path that we need to take to start. Now, once we have our model, once we do all of these things, one thing we do have to be able to balance, though, is the idea of accuracy versus interpretation. There is a balance to this. Both executives and data scientists need to understand this balance between accuracy and interpretability. Sometimes beautiful, complicated models are not useful. You know, you always hear that saying, you could be the smartest person in the room. If you can't communicate to me, then how much value really are you? And that's the same idea with a beautiful, complicated model that I can't interpret. Sometimes they're great. Sometimes they're accurate. But if I need interpretability, sometimes easy models are better. Now, unfortunately, the flip side of that coin, sometimes easy to understand models, they don't predict as well. I'll be honest. That's why they're easy to understand sometimes, is because the world's complicated. It's not straightforward. And so they may not be as good as the complicated models. So there's balance. And there has to be a balance. And knowing what that optimal balance is for both data scientists and executives ahead of time is key. We need to know how our results are going to be used and by whom are they going to be used to know what kind of balance of accuracy and interpretability we need to have. Again, story time. The best story I can tell about this is in the credit world and banking. Credit scoring models are a perfect example of balance. We want to predict well to protect the bank, but we also want to make sure that the end users are able to understand the model easily. Again, the person who's typically deciding on whether or not you get a loan is not the data scientist. So you need someone who's making that decision to easily understand how to be able to use the results a data scientist has given them. And credit scorecards are a great way of being able to do that. So what they do is they add a layer on top of a complicated model to try and break down why a model is doing what it's doing. So let me give you an example in case you've never seen a credit scorecard before. Now, this is a very, very, very dumbed down example. Okay, let's imagine your credit decision is based only on 3 pieces of information, and it is based on more than that. How many months it's been since you've missed your last payment, whether or not you own or rent a home, and what kind of income you actually have. Those 3 things seem like important decisions on whether or not a bank's going to give you a loan. And as you can see, first of all, I don't have any continuous variables here in the process at all. All of my variables are binned. And how did I get those bins? Well, again, I can get those bins through fancy mathematics, okay, decision trees and things along those lines to be able to bin my variables. And then I can put them into a machine learning model or even just a logistic regression model as categorical variables to be able to understand the value of each category coming out the other side. Again, that's a lot of complicated math, but the end user, the person who's making a decision, doesn't see all the math. They just see the glory that this is on the other side. It's just a game. You just add points. It's really easy. You have 3 variables. Pick which bin you fall in. You get that many points. If you get a high enough score, you win. The bank gives you money. Oh, your score's too low, you lose. The bank doesn't give you money. And the best part about each variable is they have levels, right? It's like, oh, if you've missed a payment in the last 24 months, that's not good. You don't get as many points as if it's been over 4 years since you've missed your last payment. Great. Same idea with owning or renting a home as well as your income. So these things make the model easier to understand. Another great way of using scorecard analysis is in the idea of fraud detection. I do a lot of stuff with fraud detection, and I'll be honest with you, there are some very, very smart detectives out there who do fraud detection. They're experts at what they do, but what they do isn't data science. And so that being the case, I need to give them something that's easy to interpret so they know exactly how to catch the bad guys. And so again, something like this would be easy to interpret. So again, balancing accuracy and interpretability plays a big role in the modeling process. Now we're moving on to the idea of validation. And executives, I want you to hold your data scientists to a higher level when it comes to validation of results. Any good data scientist should be able to validate their results. But for you to understand how a data scientist validates their results, I'm going to give you a quick 2-minute primer on some key words that you need to know to make sure your data scientist is doing you justice. So there are a variety of common validation techniques. I've listed them here. Splitting data into testing versus training, cross-validation, holdout samples, look-ahead bias. I want to run through these real quickly, executives, because I want you to be able to know when a data scientist tells you, I have a test data set and this is how accurate my data was on this test data set, that's a good thing. And if they tell you this is how accurate my data was on a training data set, you should have your little warning lights going on in your head. So a test versus a training data set, like I said, quick 2-minute primer for those who don't know. You have a complete set of data. All you're doing is taking a random sample, splitting that off. You're building your model on your training data set, and you're evaluating that model on your test data set. The way we do this and the reason we do this, we want to be able to see how well our model does on data it's never seen before. Congratulations, you built a really good model on your training data set. I could build a really good model on data that I've seen before. What was the temperature yesterday? I can tell you that. What's the temperature going to be tomorrow? That's a little bit harder to know. So again, knowing that you should be asking for results on test data is an important thing, executives. Now, of course, you could get lucky. Maybe you had a lucky test data set. So another way people do it is what they do is cross-validation. The idea of taking many different subsamples, building models off of those different subsamples, and then again, comparing across a variety of different validation data sets to make sure what they're seeing is actually good. So maybe you do the process 10 different times, have 10 different test data sets, build your model on 10 different training data sets to really see how accurate your results can actually be. Now, these things work great in what we call a cross-sectional world where we're not looking at things over time. But if you're doing things over time, what we typically do with our training and our test data set is we just hold out the end of a sample. So again, executives, if you're trying to forecast something, again, I want to forecast what sales are going to be next month. Perfect. Well, then what a data scientist should be able to do is they should be able to tell you how well they were able to forecast sales for months that their model has not seen before. So again, if I wanted to build a model on 2018 to forecast January of 2019, I should hold out some data to know how well I can predict something I have never seen before. Of course, we can do the same kind of thing with cross-validation as we do here. We can do a rolling holdout sample. Maybe you try and predict tomorrow, then tomorrow you predict the next day, and the next day you predict the next day, and so on and so forth. Again, that's just a quick little 2-minute primer on some validation techniques for executives, just so they know the kind of terminology and things they should expect a data scientist to be able to actually do for them. Another thing I want to caution executives on, and actually as well data scientists, be very careful of doing this, and executives be mindful of this. Keep us honest that we're not using what they call look-ahead bias. Look-ahead bias is when you use a piece of information you should never have known ahead of time. A great example of this is trying to predict energy usage. I want to predict how much energy this building that I'm sitting in right now is going to use tomorrow. Well, part of energy usage is how much the temperature is outside, which, you know, based on right now is really cold. So that being the case, well, temperature greatly affects energy usage. Awesome. So I'm going to look at historical temperatures and historical energy usage and try and see what's going to happen. Well, the downside, do I know what the temperature is going to be tomorrow? I mean, I have a guess. I can turn on the news and guess, but I don't actually know how good the temperature or how good that prediction is going to be and what the actual temperature is. A really good thing to be able to do is use forecasted temperatures to build the model so you know how accurate your model is actually going to be. Or at least when you validate your model, do not validate your model on actual temperatures, but on forecasted ones in your test data set. This is referred to, again, as look-ahead bias, so just be careful. Oof, okay, we can stop with the math there a little bit. Data scientists can geek out a little bit. Executives, again, all of this is tied together with leadership. Now we're into the modeling part of the CRISP DM process, the cross-industry standard process for data mining. But in the end, leadership is important throughout. We need leadership to, again, support us in the modeling process, understand that we don't know what's going to happen ahead of time, and understand we might fail, but that we will try and get a success out of it. And again, all of this is tied together with communication. Subject matter experts need to talk with everybody. IT needs to talk with everybody, as well as the data scientists need to understand where data is going to go. Both executives and data scientists need to understand the process as well as the results. And it all, again, ties together with communication. You need to be able to communicate, to be able to understand how a problem can be solved. All right, we're almost done. We've hit preparing and understanding. We've hit modeling. One little piece to go, implementation and deployment. That's all we've got left. So when it comes to implementation and deployment, model deployment is critical to the success of an analytics project. Congratulations, you built a model. If I can't use it, then it's really of no value. This is why we bring in IT from the beginning. This is why we bring in the subject matter experts, is for this very step. It's for model deployment. They are the ones who know how to best fit the results into the current business system, how to plug it in, essentially. Because again, if I can't plug in my model, then how am I actually going to use it? You can have a mathematical success, but you need to make sure you have a business success coming out the other side. And the only way, again, you're going to have a business success is that you can actually make it easy for people to use. I can go back to that idea of fraud detection. If I don't have a process that detectives find easy and available to use, then they're not going to use my fancy mathematical model. They don't care. They're going to do the process the way they've always done it. But if we can find a way to be able to make it easier on them and know how they currently do their job, actually sit down beside them and understand what they do in their job, that's how we can best understand their process and best know how to deploy our solution. Of course, I'm going to harp on data the entire time, and I love the analogy of the data barn, so we're going to continue it. So again, we've talked previously about data governance throughout the whole process, but now it comes to deciding, where are the results going to be stored when the whole process is done? Where is this new model going to reside? And as new data comes in, results from this new model being implemented, where is all that new information get stored? Because that new information is going to help reinforce my model and help train my model going forward. So again, where's all the new information coming in? The way I can best explain it with the barn analogy is really, who are the farmers in my data barn or my data pond or my data lake? Who are the people who are in charge of this process? Who owns this? Now, I'm hearkening back to what we talked about at the very beginning. I see so many people make this mistake. You told me how much value you thought you could give me. That is awesome. How much value did you actually give me? The worst thing to do is calculate an expected net present value before a project and never come back to it after the project is done. It's time to show me the value. I almost feel like the show me the money meme should be here on the slide. If you don't show me how much value you actually provided me, then again, all is for naught. Why am I going to believe you? So let me go back to the problem at the very beginning. Same process. We told the executives, hey, you know, you're spending $158,000 in 3 years on this problem that you're looking at. Even if I could save you 80% of that cost by trying to optimize the process better, I could save you $126,000. And considering it'll only take us a few weeks to solve this problem, I think it's worth your time. Well, the actual return on investment, that first year, they didn't actually save 80% of the cost. They only saved about 67%. They didn't fully believe in the power of analytics, so they still put people aside and had them sort of double check the process. But then in years 2 and 3, they basically saved 90% of the time that the people spent on this. They were able to get back to their normal jobs because the algorithm took care of it in the end. Now, again, that led to further projects later on, forecasting and making the thing better. But just making the process quicker saved them so much time and money. It saved them actually more return than what we originally projected. And so we were lucky on that regard. Maybe it would have gotten us the exact amount. Maybe it would have gotten us a little less. But again, without knowing how much return we got, what would I have done walking in front of an executive and telling them, hey, you know, I solved that problem? Well, the next best thing to tell them is how much money you actually solved for them. Which, of course, data scientists, what executives are trying to worry about is the notion of changing their company culture. See, buy-in is best achieved from communication and success. As people see victories in their process and no longer feel threatened, they'll have buy-in and support the process. Of course, success is not always the case. Sometimes failures do occur, yes, but commitment to the process will help drive and change the culture of an organization. The culture of experimentation and support leads to greater findings and drives change in an organization. The goal of any company initiative, and when it comes to a culture change in analytics or data science, is to really get to a point where business leaders in the organization are the ones selecting and driving projects. Since it's their idea, they're going to have more buy-in. Data scientists, you might want to solve this really cool problem, but you know what? If you can make the executives come up with their own really cool problem to solve, I guarantee you the executives are going to have a little bit more buy-in. Of course, we need to include all the major players in the game early and often. The more visible and the more support, the better the process will be into pushing change down the line. Of course, the big thing that I always see is all of this excitement leads to a lot of good ideas. But establishing initiatives and initial goals early will help keep focus. I've seen it so many times. small successes do equal winning big, but if you don't have a process and a goal in mind, small successes lead to an abundance of ideas, and then the data scientists are pulled in a million different directions because everyone wants to use the data science. Oh, that's great, but you have to be calm, you have to be focused and be patient, set small goals in certain groups, and then expand. Again, stay the course. You have your goals that you set, you have all the major players in the game, and now you are leading change. Just stay the course. You don't need to, again, build the Death Star in all one foul swoop. We saw how well that worked. All righty. So, again, leadership is important in this whole process, obviously. We need leaders to be able to help us in evaluation and deployment. Once the modeling is done, this is, again, where leadership can play a huge role. They're the ones that can help know how to be able to deploy it, where to be able to deploy it, and they're the ones who are making decisions from the deployment that we've actually initiated. But again, and you know what's coming, communication. All these things are wrapped around communication. How you're going to deploy something, where the data is going to be, what kind of returns and results you get, the changing culture of a company, leadership. None of these things can be done without communication. How are you going to change the culture of a company if no one knows the great things that you're doing? How are you going to be able to sell leadership on the great things that you're doing if you don't tell them how much money they're actually saving? And how are you going to be able to repeat the process if you have no clue where to deploy and save all of these great results you're getting? Communication is key in this whole thing. Communication is the underlying thing across the entire analytics process. All right, my time is almost up. Time to wrap it up here. Like I said, you have hype and you have reality. You have the notion of what people like to get excited about in data science and analytics, and you have what people need to be focused on in data analytics, and that is really the entire process. Without preparation and understanding, without a focus on how to be able to deploy and integrate a solution, modeling really isn't that important. We're not out here trying to solve cool math problems. We're out here trying to solve impactful problems. And the best way to drive impact is to understand the problem, model the problem, and deploy the solution. So hopefully what I've done for you guys today is break down some barriers. So there's no solid defined line here in between data scientists and executives anymore. It's a little bit more of a blend, and everyone gets a little bit of an opportunity to have better communication with each other. So thank you all very, very much for allowing me to be here for this webinar. Now, I guess, Emily, it's time for the question portion, I believe. But I will turn it back over to you real quick just to make sure there's no other announcements that you need me to make.
Oh, thank you so much. This was really, really, really interesting, and I took a lot of notes and have a lot to think about. But I have no further announcements, so we have about 10 minutes for anybody to ask any questions that they want. So if you want to type your question, or you can, I guess there's a raise your hand button. So Aric, if you see somebody with their hand up.
Sure. I'm trying to, this is where it gets fun, is now there's the chat window. All righty. So yeah, so we have the group chat open for anyone who'd like to click on the chat window. It's an option on the upper part. There should be a group chat. If you have any questions, just throw them in there. I'd be more than happy to be able to answer them.
So maybe while people are organizing their thoughts,
Sure.
I will ask a quick question.
Go for it.
At the end, when you were talking about how everything revolves around good communication, do you think that that's a fixable process? So if things sort of get off track a little bit communication-wise, can you come back and circle back and have good communication again? And if so, how would you do that?
Sure. No, I think it's one of those things where, yes, you can circle back, and yes, communication can be fixed along the process. It's something that I think, again, going back to that idea that communication requires both desire as well as humility. And so when communication breaks down, when communication fails, that's where, again, that humility comes in to be able to go, you know what? I made a mistake here. This is obviously not what you guys were looking for. I'd be more than happy to try and help you through this process. Let's talk a little bit more. One way to help mitigate that is constant communication throughout. One success that I've always had is sort of the idea of, obviously you have meetings with your data science team to make sure that things are going well, but also having meetings with the executive sponsors of any project and giving them updates as you go to make sure that you're on the right path. And so I think that can help mitigate any, again, that desire of being able to communicate can help mitigate some problems that you have. And, it's something where if you find out that maybe you haven't been communicating as much as you should have, again, that's where the humility comes in and goes, you know what, I think maybe we should be communicating a little bit more in this process. So that's at least the best way that I could sort of recommend.
Awesome, thanks.
No problem. Okay, so it looks like we have a question that's come in. So how do companies cultivate and grow these soft skills you describe as valuable to data scientists and executives? Oh man, that is a hard one. So great question. So how do companies sort of cultivate and grow these soft skills? It's tough, I'll be honest with you. Trying to be able to get soft skills into a company culture when they're not there can be a tough thing to be able to do. Ideally, and this is going from a pie in the sky kind of scenario, ideally you bring in people with those kind of soft skills. So for example, I don't believe that data science or analytics really is a pure academic field. I think it was created by business because of the need of soft skills. I think data science is a blend of not only math and statistics and engineering and optimization, but also a blend of business and communication and problem solving. And so trying to find good analytics professionals that are trained in these soft skills is one way to be able to help drive that company culture change. But for those people who may not have those, trying to encourage these kinds of things and getting people out of their comfort zone is probably the best way to train up and grow these soft skills. It's something where not everyone likes to be able to do the soft skills, but unfortunately they're imperative. So trying to get all the people in the right room together and have these communications with a set agenda in mind and with a goal and showing them the value from these things can hopefully drive some of these soft skills going forward to show them the value of why these things are important. At least that's the best advice I can give in those kind of scenarios. So hopefully that answers your question. Oh, looks like it did. All right. Any other questions? I'm more than happy to answer, or more than happy to answer anything you guys may have. Okay, so we have another question that came in. So often there can be a mentality that more data / big data means better results. How do you express to management that that's not necessarily the case? Oh man, funny story around that. So I was elected to a government committee, oh man, more years ago now than I'd like to admit. And our name was a big data committee. And the very first thing we did was remove big data out of our name and change it to some like analytics committee or something because of that very thing. We were trying to avoid the idea that, yes, all you need is more data and all of your problems are going to be solved. And so how to be able to express to management that big data does not always mean better results is a tough thing. It's something where the best way I've been able to do that in my career is try and show them the value that they get from the limited amount of data that they may have, and then potentially show them the gain or lack of gain from all the extra data they have. So one company was looking at collecting a lot of different data sets because they figured, again, more equals better. And the results that we were able to provide them from just the cursory data that they have drove them so far further than where they were. It helped them go, wow, I mean, that other stuff is expensive. We don't, I guess, need to. So again, trying to show that value proposition of, I can get you a lot of value for what you've got without needing to go more. But I'll be honest, this is the hardest part about the data science hype, right? Is the idea of, oh, you just need data. It's what we see in text mining all the time. Well, just get text data. It'll solve your problems. No. That's not always the case. So yeah, no, I agree. It's not an easy thing to be able to convince management of. Another question, what methods or tools are you recommending to keep communication open? And so how to be able to keep communication open? I'm a big proponent of live in-person communication. I like talking to people if you haven't gotten that already from the webinar. And so I try and go and find people as best I can and actually have, even if it's a quick, stand up 5-minute meeting, to be able to do that. But we use a lot of project management software. I've used a variety of different project management softwares over the years to be able to try and help manage those kinds of things as well, so people can see where things are in the process, understand how to be able to do that. Personally, I use one even just for myself to keep things on par for what I need to do from day to day. So I think ways to be able to do that is, again, trying to show process. And the best way to be able to show process is through some project management tools, because then people can see where you are, and that can hopefully drive some questions and drive some communication if there are any. So hopefully that helps. Oh, good. It seemed it did. Any other questions? So what advice for executives who feel that their data scientists are smarter than them, jargon, etc.? So this is one of those things where, again, trying to hold data scientists to a higher standard. I think, was it Albert Einstein that said that if you can't explain things simply, that you don't understand them well enough? I know there's a quote out there like that. Hopefully I'm getting the quote, I'm attributing it to the right person. But it's something where trying to get executives to understand and not feel overwhelmed by data scientists is also on the data scientist. It's something where, again, data scientists, we have to do a good job of trying to make sure we explain the things that are necessary, not necessarily the things that make us sound smart. And so, again, I go back to that idea, you could be the smartest person in the room, but if you can't communicate it with somebody, then you're not really of any value. So executives, you are an executive for a reason. You are very smart at what you do. I know there's been many executives that I've met that I'm like, you know what? I can't do that job. I'd rather go do my data science. And so it's something where not feeling overwhelmed if you're an executive just because you have someone that might know more math, fancy things than you do. That's all right. You can probably, circle them when it comes to business knowledge. So it's just, again, trying to reach the person on terminology they understand. And then, again, that's on us too, data scientists, to make sure that we're not trying to sound so smart. Again, the goal is to try and communicate effectively, not in, trying to make ourselves look better. It's a pride thing, I think. Awesome. Well, if there are no other questions, I guess we can give you guys 2 minutes back. Quickly, eat lunch, you can go back to work. So thank you all very, very much for allowing me to be here today. Thank you, Emily. Thank you, Sujit, for inviting me to do this. This was a lot of fun. I look forward to giving another one of these in the near future. But again, thank you everyone for allowing me to be here. It's been a pleasure.